All right, so section 4.3, quadratic functions. So quadratic functions have a standard form, and that's the form we'll start with. There's a couple other forms that we'll deal with, but standard form is standard, so we're going to talk about it first. F of x is equal to ax squared plus bx plus c is standard form for a quadratic. The shape that the graphs make are a parabola, either pointing up or pointing down, since we're dealing with functions. Won't be any sideways parabolas or anything with what we're dealing with, just up and down like that. And the determining factor about whether it opens upward or opens downward is the value of the number in front of x squared. Always going to decide. If the a, excuse me, is greater than 0, what kind of number is it? What numbers are greater than 0? Positive number. So that number in front of the x squared is a positive number. It's going to open up. And it will have a minimum at the vertex. Okay, so open up, that's that picture. I say open up, that's what I'm talking about. Opening in that direction. If A is positive, that decides that. If A is negative or less than 0, it's going to open downward. It's going to have a maximum at the vertex. And the vertex is that single point down at the bottom or up at the top. So those points at the bottom and the top are the vertex is. I'm going to calculate that shortly. Okay, so excuse me. With that being said, the vertex is an absolute max or min. Depending on A. Depending on what A is, whether that vertex is an absolute maximum. If it's an absolute max, that means A is a negative number that looks like that. If it's an absolute minimum, it's A is a positive number that looks like that. So when we look at the graph, it can tell us all of those things there really easily. But we can look at the equation and tell what's going to happen as well. Okay, so the domain of just a general quadratic function is going to be from negative infinity to positive infinity, all real numbers there. Okay. The range is dependent upon A. So it depends on A. And the Y value of the vertex. Okay. The vertex being that absolute maximum or minimum. So if it's opening up, your range is going to start at that Y value of that vertex and go to positive infinity. If it opens downward, A is negative, then you're going to start at negative infinity and go up to whatever that Y value is. So the range just depends on what A is, so it changes with the problem. But the domain always going to be negative infinity to positive infinity for just a regular function. And we get into the context of a word problem, that kind of drop that idea, but just in general, the problems there. So let's talk about the different pieces that we're going to try to find when it comes to quadratic functions. Okay, so the first piece that we're going to try to find is what's called an axis of symmetry. When we talk about an axis of symmetry, we're saying, where can I fold this parabola and get it to match up perfectly on each side? And the equation of the axis of symmetry is always x equals negative b divided by 2a. And that a and the b come from the coefficients in the original equation there in the standard form. So axis of symmetry is always going to be that equation x equals negative b over 2a. And when we find that axis of symmetry, we get half of the vertex for free. The vertex is going to be this ordered pair where the x value is the negative b over 2a, whatever that works out to be from the axis of symmetry. We get that for free. And then to get the y value that goes with that, we plug that into the equation and work out the function value for that particular x and get the y that goes with it. And that gets us the vertex. And then from there, we could find the range for this, for whatever quadratic that we had. Now, we're also going to find the intercepts. What kind of intercepts can we have? We can have x-intercepts. We can have y-intercepts. X-intercepts are a little tougher to find. Y-intercepts are always, if it's in standard form, going to be at 0 and then plug in a 0 for x. So it's always, no matter what kind of equation that we do with quadratics, usually this number is the c that's on the end if it's in standard form. But if it's in another form, it's still the same process. You plug in 0 for x, work it out, and that's where you're going to get your y value for your y-intercept. Okay? Plug in a 0 for x. Work it out. That's your y-intercept. X-intercepts with quadratics, there's two different ways to do this. Both of them start with set the function equal to 0. Okay, we're going to set the function equal to 0 to start off. Okay, and then we get options as far as how to solve them. One of those ways is factor, and we'll talk about factoring here in a little while and get the specifics of how to factor a quadratic. And the other way would be with this thing called the quadratic formula. And the quadratic formula is nice because it works every single time. Factoring doesn't always work. Quadratic formula does, even if we have complex solutions or just numbers we're not as familiar with. So the quadratic formula is nice. The quadratic formula is this. X equals negative b plus or minus the square root of b squared minus 4ac. All of that is divided by 2a. That's the quadratic formula. And in my high school classes, I make them memorize this, and you guys need to memorize it as well, because they don't give them this formula on the ACT or the end of course test for that matter, and don't give it to you on the final either. But I make them memorize it. I'm not really good at memorizing things that matter. I'm good at memorizing things that don't matter. But things that do matter, I'm not real good at. So I try to come up with ways to make it a little easier to remember. And the way that I do this one is I sing that formula to row, row, row your boat. That little melody. If you sing that to that tune, it's x equals negative b plus or minus radical b squared minus 4ac divided by 2a. And then you remember it, or that's how I've remembered it since I was in high school. I had a high school teacher that way. I had a professor in college that put everything to the. Y'all probably don't know Gilligan's Island. Y'all ever watch that show? It comes on TV Land somehow. It's over. But I had a professor in college, and we thought it was a great trick until everything we had to memorize he put to the same tune. It was always Gilligan's Island's thing, and it works the same way. But the idea is just memorize that formula, and that's the way that I memorized it, is just to sing it. And the A, the B, and the C all come from the A, B, and the C from standard form. It has to be in standard form to use that formula. Okay, so if it's not in standard form, we can't use that. We either need to put it in standard form or go a different direction out of that. Inside of that quadratic formula, there's this thing called a discriminant. The discriminant discriminates what kind of answers you have. The discriminant is the stuff that's underneath the square root. So when you got the quadratic formula there, the discriminant is all of that stuff that is underneath the square root. Okay, so when we talk about the discriminant, it's that stuff. What kind of number underneath the square root decides what kind of answers we have? If that number is negative or less than 0, b squared minus 4ac is less than 0 or negative, we have complex solutions, which also means no x-intercepts. It won't cross the x-axis. If we look at the graph and we see that it doesn't cross the x-axis, we know that the discriminant must have been a negative number out of that, tying it all together there. If b squared minus 4ac is equal to 0, then we have one real x-intercept. If it's greater than 0, we have two real x-intercepts. If that discriminant is less than 0, we don't have an x-intercept. If it's equal to 0, we've got one. If it's bigger than 0, a positive number, then we're going to have two real numbers that are x-intercepts out of that. So what we're going to do is we're going to take some quadratics and try to find all of these things. Okay, so we're going to start with them in standard form, and then we'll start adding in some of the other forms here out of that. So let's start with example A. F of x is equal to x squared plus 7x plus 12. We have a quadratic. That one I know is in standard form because it has ax squared plus bx plus c. It's got an a, a b, and a c. What's a for this problem? What's in front of x squared? 1. So a is 1. B would be 7, and c is 12. Okay, so all of just that list there can help us figure out all of this stuff, because we're going to find those things. We're going to find the axis of symmetry. And remember, it had that formula x equals negative b over 2a. So we're going to just plug in the stuff from our list. Negative b means take the opposite of positive 7, which is negative 7. Over 2 times a, and a is 1, so that'd be negative 7 over 2. So the axis of symmetry is x equals negative 7 over 2. That's our axis of symmetry. Finding what x is equal to when you use that formula. All right, quit flickering. There we go. All right, now we can then take that and find the vertex. We're going to relate this to the graph. We're going to graph it with our calculator in just a second. Relate all this stuff to that. So the vertex, the x value of the vertex is automatically the same thing as the axis of symmetry. We don't have to think about that at all. It automatically matches up. This goes with that. To find the y value that goes with that, we take that x value, negative 7 over 2, and plug it in the place of x in that problem. Plus 7, negative 7 over 2, plus 12. So I'm just picking up the x value from the axis of symmetry, that becomes the x value of my vertex, and taking that answer and plugging in for x in the original problem. and working that out. So parentheses, -7/2 squared plus 7 parentheses, -7/2 plus 12. And I get a decimal answer, I want to put it as a fraction. So math, enter. So -1/4. And that's our vertex for that. So if I look at the graph of this, I'm just going to my calculator and hit y equals, and I'm just typing in that equation, x squared plus 7x plus 12. And I'm just going to glance at the graph of that and see these things happen. So right here at -7/2, we know that that's -3.5. So -1, -2, -3.5 would be right there. We see that lowest point in the graph. That's where the vertex occurs. So there's where that is. That should be, the y value for that should be -1/4, right? That doesn't look right. Make sure I typed in the problem correctly. I did not. I typed in 11 instead of a 12. That will make a difference. That looks a little better. All right, so we see the same x value, the -3.5, and then the y value is -1/4. That makes more sense. That looks much better. You can see it there. And so we can see that stuff happening. We see this thing crossing the x-axis in how many places? 2. It's got a spot right there, a spot right there. We could estimate those pretty easily, that it should be maybe -4 and -3. I hope that's what they are. We're going to find out as we solve this. But that's what we're estimating them to at least be close to. Okay? So if we're going to find those intercepts, so the intercepts would be the next thing we're going to look for. If we're going to find those intercepts, if we find the y-intercept, because that's the easiest one, I'm going to find that first. So that means you plug a 0 in the place of x. So any equation we deal with the entire semester, if you're going to find the y-intercept, just plug a 0 in for x and work it out. So we get this this y-intercept at 0, 12. And if I look at my graph, I can't hardly see it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it looks like it's veering toward where 12 would be on my graph there. So it looks like I'm on the right track there for sure, based on my graph. Now I want to find the x-intercepts. And this is the part that's a little tougher, because we have to take the original function and set it equal to 0. So we're taking x squared plus 7x plus 12 and setting it equal to 0. Okay? And we have two options as far as solving this thing. We have either quadratic formula or factoring. And I want to show you both and work through this using both methods, just so that you've seen both ways. So I'm going to do factoring first. So if this is if I use factoring. If I'm using factoring, I use I call it the X method for factoring, but it's just a way of organizing your thoughts. And the way if it's in standard form, the way the X method works is you take A times C to start off with. So A in this case is 1 and C is 12. So we take 1 times 12. So, and you always put that number in the top. A times C is always what goes in the top of the X. And then B always goes in the bottom of the X. In this case, it's +7. Okay. So I'm just trying to organize my thoughts. The way I learned factoring when I was in school was guess and check. That may be in the way you learn too. You just guess what numbers multiply to be 12. Or you just open up a couple of parentheses and start putting numbers in there and see if it works. That's how I learned. And it wasn't the greatest way to do it. This at least organizes a little bit better. It's still kind of guessing and checking, but at least you're not running around quite as much. Okay, so here's what we got to look for. We got to look for two numbers that multiply to be 12, but they got to add to be 7. So it's got to multiply to be this up top. A times C gets the top number. B is the bottom number. It's got to multiply to be 12 and add to be 7. So the numbers that multiply to be 12 I know are 6 and 2, but 6 plus 2 is 8, right? And then 4 and 3, hey, that multiplies to be 12 and adds to be 7. So that's why I know that this is going to be 4 times 3. Now I take those two numbers from the sides and I put them in the middle of the problem and replace the 7x with them. So instead of 7x, now I've got 4x and 3x. Okay? And when you were learning factoring in school, if it had 4 terms in it, the trick that we taught you was grouping. That you group the first two together and try to factor them. So if I group these two together, what do x squared and 4x have in common? X, and x would be their GCF. Okay, so x comes out to the front, and then that leaves x plus 4 on the inside. And then I look at the second pair, and I usually just underline those because they get a lot of parentheses up here. So the underlined set, what do 3x and positive 12 have in common? They both divide by 3. So I'm going to pull out a 3 to the front. And whatever sign is right there is always going to come down here. And then what's left in those parentheses? What times 3 gets me 3x? Well, x does. What times 3 gives me 12? 4. Notice these parentheses match. If they don't match, something went wrong. Does that make it a lot easier to factor? It probably was like a foreign concept to you if you didn't learn it that way in high school. Because I didn't learn it that way in high school, and this was a foreign concept to me when somebody showed it to me, and I was like, oh, my life could have been a lot less stressful. It'd been a lot quicker to get things done. So now, we're not quite done, because now we've got to set up the two factors. X plus 3 is a factor. That's the stuff that's in front. And the other factor is the x plus 4. Now, when I learned to factor in school, they told me, set up two parentheses. And since you know it's x squared in the front, you know x goes in the front. And then start guessing numbers to get the ends of it. And you would stumble into 4 and 3. But it might take, if you're not good at your multiplication tables and you're not really good at factoring, it takes you a while to get there. But this way, it's kind of more of a systematic approach to it. It's a little more organized. It makes it easier. Now, the last step is to take each of those factors and set them equal to 0. Because what this says is that you got something times something else, and it equals 0. So that means at least one of those is equal to 0. It could be both of them. So we're going to pretend that it's both of them. We're not pretending. It could be. Very well likely is, because 0 times 0 is also 0. So I said x plus 3 equal to 0, x plus 4 equal to 0, and I solve those. So negative 3 and negative 4. So our x-intercepts are at negative 3, 0 and negative 4, 0. The same places we saw on the graph where they crossed. Oh, it may not be. Yeah, the x value is what you find, and 0 is the y. Yeah, it's always on the x-axis. That's right. Good job. All right, so I'm going to show you quadratic formula. Quadratic formula. Here's the thing about factoring. Factoring doesn't always work. Not every polynomial factors, or not every quadratic factors. That's what we're dealing with. So we've got to have a way to solve them when they don't. Quadratic formula is a good way to do that. It will get you the same answers as factoring does, just in a different way. Okay, so we should end up, when we solve this, we should get negative 3 and negative 4. If we don't, we did something wrong with quadratic formula. Okay, so quadratic formula, x equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. So I'm plugging in the a, the b, and the c. So negative 7 plus or minus 7 squared minus 4 times 1 times 12. All of that's underneath the square root. and then all divided by 2 times 1, because that's what A is. And I'm working that out. -7 plus or minus, that's going to be 49 minus 4 times 12 would be 48. And then 2 times 1 is 2. So that means that's going to be -7 plus or minus. What's 49 minus 48? 1, right? What's the square root of 1? 1. So now I have this kind of mumbo jumbo going on down here, and I got to just break that apart and say, okay, what's -7 plus 1? And then what's -7 minus 1? And to divide those answers by 2. So -7 plus 1 divided by 2, that's going to be -6 divided by 2 is -3. -7 minus 1 divided by 2, that's the -4. Again, same answers I got by factoring. I get quadratic formula. It should not be different. But again, quadratic formula always works. Factoring doesn't always work. So be careful about that. All right. Now, last thing we want to talk about with this particular example is the domain and range. So we mentioned that earlier. What do we know the domain of this thing is? Because it's a quadratic function. Automatically, we should know that it is -infinity to positive infinity. We don't even have to think about it. Because it's a quadratic function, it's going to be that. Now, when I look at the graph, what direction does that thing open? Up. What's the lowest y value? It's that one down here, right? What is that y value? -1/4. Oops. -1/4. And it's going to go up toward positive infinity. Is there a bracket or a parenthesis on the -1/4? Bracket, because it's a point on the graph. It's the vertex of that. The vertex is also a maximum or minimum for this particular problem. Minimum, because it's the lowest. So I'll put that somewhere near the vertex, that it's a minimum. How about that? So anytime when we start doing application problems and they start talking about maximum height or minimum value, something like that, maximum and minimum relates to vertex always. Okay, so when you think about maxes and mins, you're talking about vertex. Maximize, minimize, vertex. Always thinking vertex when you deal with that. Okay, so when we get to the application problems, keep that in mind. Okay, so that's one in standard form. Let's talk about the next form. And we'll work our way through all of those things with it too. So the next form is called vertex form. You might see, if you Google this, you might hear it called shifted form. But vertex form is what University of Tennessee calls vertex form or shifted form. So if you Google it, if you find a YouTube video talking about shifted form, it's the same thing. Okay, and the way it works is you have a function. There's that A, the same A that we had with standard form. That's the same A. And then we have a set of parentheses. X minus h squared plus k. What this does is it takes the parent function, the x squared function, and shifts it h units to the right, k units up and down. The A decides how wide it is, whether it opens upward or downward. Okay? The A still decides everything the same way. The good thing about vertex form is it has a shortcut for the axis of symmetry and the vertex. That's why it's called vertex form. Okay? The axis of symmetry is always x equals h. Whatever the h is inside of there, We change the sign of it, bring it out, and that's the x value for the axis of symmetry. Well, what do we know about the vertex and how it relates to the axis of symmetry? Whatever the axis of symmetry is, that's the x value of the vertex. The y value of the vertex is that guy. It's the k. So it's called vertex form because you can look at it and see the vertex in the places there. Okay? Always the opposite sign of what's in parentheses to get the axis of symmetry and the vertex. Now that vertex, again, decided by A. If A is greater than 0, it's a positive number. It opens up. If A is a negative number, opens down. So same rules about A as it was with standard form. That hasn't changed any. Okay. When it comes to the intercepts, how do you find a y-intercept? How do you always find a y-intercept, no matter what kind of problem you got? Plug in a 0 for x, right? We're doing the same thing for the y-intercept here. It's just going to be a little bit different order of operations problem to work out, but that's what you do. It never changes. Okay. To find the x-intercept, we set the problem equal to 0. And I tend to solve these by square roots. That's the easiest method, in my opinion, to solve. Ones that are already in vertex form. Your other option would be to multiply this dude out and get it back to standard form, and then either do factoring or quadratic formula. And that's just a lot of extra work that you could just solve this by square roots. We'll go through an example and show you how to solve by square roots. And it makes it a little bit easier there. All right, so also domain and range. Talk about those things. Domain, it's a quadratic function, right? So what's the domain? On the money every time. The range, because it's in vertex form, if A is greater than 0, that means it's going to open up. It's a positive A value. So it's going to open up. So that means our lowest value is at K, and it goes to infinity. We get a little bit better here on being able to look at it and get the range because it's in vertex form. We know that vertex is either the lowest point or the highest point. If A is less than 0, a negative number, then it goes from negative infinity up to K, like that. Depending on what A is, what the range does out of that. Okay, so vertex form, really, if you got to have a vertex, that's the best form for them to give you the problem, because you just look at it and get it. Now, as far as the x-intercepts, this is not the best form for me to get x-intercepts out of. There's actually a better form for x-intercepts than this, but we'll talk about that in a little bit. But let's look at an example of something that's in vertex form. So let's call this example B, g of x, 2 parentheses x minus 3 squared plus 4. We're going to find all those things that we found with example A. But the good news is, because it's in vertex form, 2 of them are really, really super easy to find. Okay? Because it's in vertex form, I know that the vertex is going to be right here. It's going to be these numbers right there, 3, 4. The opposite sign of what's on the inside the parentheses, so that's a minus 3. So when I pull that out, it's a positive 3. and then keep the same sign of the stuff on the outside. So if the vertex is 3, 4, what's the axis of symmetry? X equals what? 3. It's always matching up. Axis of symmetry and the x value of the vertex should always be the same on quadratics. Always, always, always. All right. Now, we found the vertex. We found the axis of symmetry. What do we know about that vertex? Is it a maximum or a minimum value based on what A is? It'd be a minimum. If we're ever in doubt, all we've got to do is go to our calculator and type in the problem. 2 parentheses x minus 3 close parentheses squared plus 4. So I'm just typing that equation in just like it's written and hitting graph, and I can see the picture of it, showing up there. So I see that going on there. And then, so that's a minimum value. And let's get the intercepts for that. That's 13. I'm going to abbreviate intercepts. Y-intercept's the easiest one because what do you do to find a y-intercept? Plug in a 0 for x. 2 parentheses 0 minus 3 squared plus 4. That'd be 2 times 9 plus 4. 22. So the y-intercept is at 0, 22. And if I glance at my graph, I can see that, hey, it's going up pretty good ways there, but it's going to veer into the y-axis somewhere way up there. Looks like it probably would be 22. All right, let's get the x. Let's try to find the x-intercepts. What do I know about it from my graph? Will this one touch the x-axis? No, I know by looking at my graph it won't have that. But I want to take you through the steps of finding zeros of a polynomial, even when they are not real ones. We can find the complex solutions to this too, which we're going to have to do later on anyway. So I want to take you through the steps of doing that. Okay, so what we're going to do is we're going to take this problem, 2 parentheses x minus 3 squared plus 4. This is to find x-intercepts or zeros or roots or solutions, whichever one you're going to call it. And we're going to set it equal to 0. So first step would be move that k value over. So I'm going to subtract 4. What I'm trying to isolate here is the stuff that's in parentheses. And I would divide by the 2 because it's not in the parentheses. And that's going to give me x minus 3 squared is equal to negative 2. And how do you undo squaring something? What's the opposite of squaring something? Take the square root of both sides. So if I take the square root of both sides, that's going to give me x minus 3. On the right-hand side, I've got to remember that when I take the square root of a number, it could be the positive number or the negative number. Plus or minus has got to go in front of that. Because if you think about a number other than negative 2 that's in there, like if you had the square root of 64, we know that that's 8. So 8 squared is 64. But also, if you square negative 8 times negative 8 is also 64. So that's why we need the plus or minus in front of that always. And then we can simplify that. You guys remember what the square root of a negative does? What comes out? Maybe from in the past, the dim distant past. Anytime you take the square root of a negative number, an I can come out. The imaginary number system or complex number system, imaginary numbers. So this is I radical 2 or I square root of 2. We're almost done because this is a complex solution. We knew from our graph that this didn't cross the x-axis. If you get an imaginary or complex number, you know it doesn't cross the x-axis anymore. Okay, we knew from our graph it didn't. But this is the process for solving by square roots. So then I would add 3 to the problem. And because 3 is not an I, it doesn't have an I on it, those are not like terms. So I just end up with 3 plus or minus I radical 2, and you just stop right there. Those are the solutions for this, but they're not technically x-intercepts. So when if it asks for x-intercepts, you just say there are none because it doesn't cross the x-axis. If it asks for roots or zeros or solutions, then yeah, you can find those, but that's later on. We'll talk about those later as we go a little further. Okay, so solving by square roots, the idea, get the squared part by itself, and then take the square root of both sides and make sure you put the plus or minus in front of the number that you're doing there. Okay. All right, let's talk about this last form. I told you there was another form that was better for x-intercepts. This form is the one, okay? This last form that we talk about with quadratics is what's called intercept form. A lot of times you'll catch me calling it factored form. Intercept form, factored form, it's the same thing, okay? M and N are just numbers. X is still X. A is still the same A we've been dealing with for the whole day. Okay? Nothing's changed about that. My suggestion when it comes to all of these things that we've been finding, so axis of symmetry, and I'm going to abbreviate, and vertex, for these two, I would multiply it out and get it into standard form to get those two. There are a few, like some shortcut formulas that I could give you, but I think they're more confusing than they are helpful. My suggestion is to just multiply the problem out into standard form and then use the rules from standard form. You're going to use standard form more than you do anything. That's why it's called standard. I mean, it's used the most. These other forms are not used as often. So I don't like to spend a lot of time learning special formulas for other forms out of that. But when it comes to the intercepts, this form is better for the x-intercepts anyway. To find the y-intercepts, how you do that? It's redundant here, but plug a 0 in the place of x and just work it out. That's a y-intercept every single time. Okay. To find the x-intercept, if it's already in factored form, set each factor equal to 0. That's all you have to do. It's just set x minus m equals 0, x minus n equal to 0. It worse as the day goes on. M0, N0. We're going to do an example out of this. Domain, what's it going to be? Quadratic function. So what's domain on quadratic functions? Always negative infinity to positive infinity. Never change. Okay? The domain's still the same. It's at negative infinity to positive infinity. So let's write that down. Domain. Negative infinity, positive infinity. The range, again, it's going to go back to exactly like it was with standard form. If A is positive, it's going to be from whatever the y value of the vertex is. So let's just go back to the vertex. and then negative infinity. So I'm going to put a blank there. And those blanks come from the vertex. What we noted in the standard form. Remember, to get the axis of symmetry in intercept form, we're going to multiply the problem back out into standard form to get that. Okay, so let's look at a problem that is in intercept form or factored form and get all of this stuff out there. So h of x is equal to -3 parentheses x minus 4 x plus 2. Something like that. Okay. Not too big of numbers at all. So I know I'm going to do these things, but I'm going to try to do them in a maybe a better order so that I can not have to go back and forth. I know I'm going to get the axis of symmetry, the vertex, and the intercepts. Because it's in intercept form, I'm going to start with intercepts and do that part first. Okay. So we'll get the y-intercept. Let's plug a 0 in the place of x. -3 parentheses 0 minus 4. 0 plus 2. And just work that out. So it'd be -8 times -3 should be +24. So our y-intercept is 0, 24. Okay. The x-intercepts, because it's in intercept form, the x-intercepts should be the easiest thing we have. When it was in vertex form, the vertex was the easiest thing we had. In standard form, really wasn't none of, the y-intercept was the easiest thing to have. It's really not that hard no matter what. So with x-intercepts, we're taking that problem, -3 parentheses x minus 4 parentheses x plus 2, and we're setting that whole thing equal to 0. So I'm going to get rid of this -3 by division. Get x minus 4 parentheses x plus 2 in parentheses. And 0 divided by -3 is always going to be 0. So now it goes back to that idea when we were doing factoring. What do I do with each one of those sets of parentheses to solve this problem? I set each one of those equal to 0. So x minus 4 equals 0, x plus 2 equals 0. And that's going to give me x equals 4, x equals -2. So that'd be 4, 0, and -2, 0 would be my x-intercepts. I can verify that by looking at the graph of this thing. Y equals, I'm just going to type in -3 parentheses x minus 4 close parentheses, another set of parentheses, x plus 2. Hit graph. And I see that thing crossing the x-axis here at +4 and -2. I type the right problem in. Yeah, x minus 4. And it looks like, it definitely crosses the y-axis somewhere way off screen up here. And it makes sense that that's 24. So it's not way off out of that. It opens downward. So that helps us as far as the x-intercepts. It also helps us as far as the range goes when we go to do that. Okay. So we found the intercepts. We started with that because of the format it was in. It was in the factored form or the intercept form. To find the axis of symmetry and the vertex, my suggestion is to multiply it out and put it in standard form and then use those formulas. Okay, so if I'm going to multiply this thing out, f to the h of x. I'm going to multiply the parentheses stuff first and then just multiply whatever I get times -3 at the end. So x times x is x squared. X times 2 would be plus 2x. And then I'm multiplying -4 to stuff. So that'd be -4x. And then -8. Excuse me. And then I'm simplifying that to be -3 parentheses x squared minus 2x minus 8. So I put the like terms together in the middle there. What I did. And now I'm going to distribute the -3. I mean -3x squared plus 6x plus 24. Excuse me. Now I'm going to take that and do the formulas for vertex and axis of symmetry. Remember, the axis of symmetry was x equals -b over 2a. So I got to find that part first, and then I can find the rest of the vertex. So -b would be -6 over 2 times -3. Be -6 over -6, which is 1. That's nice. That's an easy number to plug in. So x equals 1 is my axis of, symmetry. Now, I know the x value of my vertex will be 1. I just need to find the y value of my vertex. So I'm plugging in 1 in the place of x in that problem. So h of 1. -3 parentheses 1 squared minus 6 parentheses, plus 6 parentheses 1 plus 24. And that'd be -3 plus 6 is 3 plus 24 would be 27. So the y value is 27. Now I found all of that stuff for that problem that was in intercept form. What I want to do now is find the domain and the range. Remember, we talk about those things pretty regular. Domain should be easy. Negative infinity, positive infinity. The range. Is our vertex a maximum or a minimum value? So we got to decide which way does this open. Does it open up like this or open down like that? Down, because why? The negative in the front. So it opens down. So that means this has got to be a maximum. So that means our range is going to start at negative infinity and go up to the y value of your vertex, which is 27. And I should put a bracket on the 27. There's our domain and the range. So anytime they ask for range, you're going to have to find the vertex if it's quadratic. And if it's in vertex form, yay, it's not hard to do. If it's in standard form, has a little bit of work to do. If it's in intercept form, there's a little bit more work to do to get there. But range is dependent upon the vertex. So anytime they're talking about range, you got to think vertex has got to be part of that. Okay, so tying those things together. Now, very last thing in this section, and then we'll go to the application section. You may think the application's actually easier than this stuff, just because it's not as much all the time. So this one, we're going to write the equation of the quadratic. That has intercepts 3, 0, it's an ordered pair, -5, 0, and 0, 8. So it gives you 3 intercepts, 2 x-intercepts and 1 y-intercept, and asks you to write the equation of that quadratic. So what we're going to try to do is write that in the best form possible. So if they gave me all of the intercepts, what form should I start in? Probably intercept form. If they gave me a vertex, what form should I start in? Vertex form, right? So that's the idea here, is that we get whatever they give us, we want to start with the form that's closest to that. Very rarely will you start with standard form. They're going to give you either intercepts or they're going to give you a vertex in another point. Okay, here they gave us all 3 intercepts that we have. So I'm going to start by taking intercept form, a x minus m x minus n, and I'm going to plug in the stuff I know. I don't know what a is, but I know that m is either 3 or a -5. So I'm going to do x minus 3. And this one will be x minus -5, but double negative turns into a plus, right? So we'll start with that. And now I can take the other point, or the third point that I haven't used yet. I'm going to use the x-intercepts because that's the intercepts the intercept form uses. I haven't used this ordered pair yet. I can use that ordered pair to find out what a is. Because this is x and this is y. These are x's. F of x is the same thing as what? Y. It's the same thing, right? So if I take this problem and I plug in 0 for x and 8 for y, a is times -15, divide by -15. I get a fraction. That's okay. -8 over 15 doesn't reduce. So my problem, -8 over 15, parentheses, x minus 3, x plus 5. I've written that in intercept form. What if they ask for that in standard form? Well, I've got intercept form. I could get to standard form from intercept form by multiplying everything out. So if they ask for it, this is intercept form. Standard form, I take that original problem, -8 over 15, x minus 3, x plus 5. I'm going to multiply everything out. X times x is x squared, plus 5x, minus 3x, minus 15. Simplify, -8 over 15, parentheses, x squared plus 2x, minus 15. So a lot of multiplying there, just algebra, distributive properties, all I'm doing. And then I'm distributing -8 over 15 to that. So that's -8 over 15 x squared minus 16 over 15 x plus 8. And there is finally our standard form for that. So standard form given those points. Now I want to show you how you can use your graphic calculator to get some of this too. Okay? So with the graphing calculator, you know how we did the linear regression last week? You can do quadratic regression. The key with quadratic regression is you got to have more than 2 points. So if you only have 2 points, it doesn't work too great. But go to Stat, Edit. We're going to do the same things that we did last week, but we're going to do it with these 3 ordered pairs. So we had 0, 8, I'm just putting in the y-intercept first. -5, and then 3, and just get the y values in list 2. So that would be 8, then 0, and 0. Okay. So I've got to have the 3 points there, and then I can hit stat and go over to calculate, and I'm going to do a quadratic regression with those 3 points. So that's choice number 5. I want to make sure wherever I put my x values, or that list is there, wherever I put my y values, that list is there. I don't need anything in frequency list. I'm not going to store that equation. I'm going to write it out, or just copy it down. I'm just going to tell it to calculate it. Negative 0.53 repeating, and then B is negative 1.06 repeating. C is 8. I know 8's the right C value because I did my standard form a while ago. That is right on it. The R squared there, you may not have yours turned on, the stat diagnostics, and that's okay. But what that tells me is that fits perfectly. A 1 right there means it fits perfectly to the points, that this equation. Now, if I did the math, if I did whatever was in front, -8/15, -8 divided by 15. There's that A value. I got it right. And if I did -16/15, I get the B for my standard form of that. It's only helpful really to get standard form. You don't get any of the other forms with it from that, but it is a very, very good checking tool to make sure you got it right, or to be able to narrow it down between equations when you're asked to find those things. Okay, so tough stuff there. A lot of information in that section there about quadratics. Just takes a little bit of practice getting there with that. All right, so let's get to that last section of applications. And I went ahead and made you a copy. I'm going to use a PowerPoint because these are word problems, so you don't have to copy them down. Spend a lot of time writing down the word problems that are written there. So I made you a copy of those for that. So we're going to try to go through this. All right. All right. So first one there is a farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Most. What does most make you think about? What parts of the quadratic? What's another word for most? Mm-hmm. Maximum. And maximum should make us think about what part? The vertex of a parabola. Okay. So when we think about area of a rectangle, how do you find area of a rectangle? Length times width, right? Okay. So when we set up our problem, we're going to think about a rectangular field that has a length and a width. They use W and X here because we didn't know what they were. You could have used W and L. It doesn't matter. And we know that there's 2,000 yards of fence, and we're going to put it around our field. Okay. So around the field is perimeter, right? So that's where the 2x plus 2w equals 2,000 comes from. Perimeter, because we're putting the fence around the field. Okay, we're putting the fence around the field. We know that this is what's going on. We know area is length times width, or in this case, x times w. Okay. What we then need to do is solve our perimeter formula for one of the letters. Okay, so that we get a problem that only has one letter in it. Because if it's got 2 letters in it, we can't solve it. But if it's got 1 letter in it, we can do some stuff. Okay? So I take the 2x plus 2w equals 2,000, and we just pick to solve for w. Could just as easily solve for x. It doesn't matter in that case. Okay? We solved it for the width and got, it worked out to be 1,000 minus x. Okay? And what we're going to do is we're going to take that part and we're going to replace the W in the area formula. Area is length times width. Length times width. We solved for width and got this, so we can replace that in here. And then all I did here was distribute the x to get something close to standard form. It doesn't have a C value in this one. That's okay. But we get something that's close to standard form. And then they want us to find the most area. So that means find the maximum area of that. So to maximize that, we need to find the vertex of this quadratic. So we do negative b over 2a. So here's our quadratic function that we're dealing with. We're going to find the vertex of that. Here's a graph of it. If you graph it with a calculator, you'd have to zoom out a long ways. That's why I don't pull it out the graphic calculator. We know it looks like that because it's got a negative a value. So we know it opens up like that. It has a maximum point because it's got a negative in front of x squared. So we have negative x squared plus 1000x. And then we take that and find that vertex by using the formula, negative b over 2a, same formula from before, negative 1000 divided by 2 times negative 1, it's going to be positive 500. That's the x value. We just need to find the width value, to find the dimensions that maximize it. If I plug that into the function, the maximum area, plug in 500 for x. So what I've done there is I've taken this function, I found the x value of the vertex, plugged it in to find the y value of the vertex. The maximum area that we can enclose is the y value of the vertex. 250,000 square yards. So the dimensions, well, if the width or the x is 500, so you got 2 of those, that's 1,000. How much is left for the width? That's another 1,000. Split it into 2. It's a 500 by 500 feet, a square field. Anytime you maximize a rectangle, the area, if you want to maximize the area, it's always going to be a square. That's just the way the math works. It's always going to be that way. So anytime we talk about most or least, maximum or minimum, you're talking vertex. You got to think, build a quadratic, find a vertex. That's what you got to know about that particular problem. These are the easier ones. Okay, so this is the easy part. When we get to the ones with the data. Okay, so bottom of the back of the first page there. Okay, you got that data. Here are the x values. This is percent divorce. That's going to be our y values. Okay, so we're going to put those in to our calculator in the tables. Okay. Oops. Back up. All right, so I'm going to go to my calculator and I'm going to put those values in. So stat, edit, and I'm going to clear out my list that I was using earlier. And I'm going to put in those values. So I have 22, 27, 32, not 23, 32, 37, 42. Copy's not real great. It got tiny on me. Smaller than I thought it would. 60, 70, and 80. Then I'm going to go over to list 2 and I'll put in that percentage. So 0.9, 3.5. Is that 3.5? No, it's 3.6. 3.6 for the second value. Third value is 7.4, 10.4, 12.7, 15.7, 16.2, 13.1, and 6.5. Okay. So we put those in the list out of that. Now let's go back to our PowerPoint and see what they're asking us to do. They're saying, draw a scatter diagram of that to see what kind of relationship it is. If I did a scatter plot with my calculator, I go to y, or I go to second y equals, hit enter, turn that plot on, and then hit graph. And then I'm going to hit zoom 9. What kind of shape do we see here? Good little parabola shape. So that tells us, hey, if I'm going to fit an equation to this, it's probably going to be quadratic. If it were a straight line, we know we're trying to do a linear regression. Okay, so if they don't tell you, hey, this is a quadratic relationship, then the scatter plot can show you the picture and you kind of get a better idea of what's going on there. So we did a scatter diagram with the calculator. Graph, find the quadratic function of best fit. So that's exactly what we want to do there. We want to hit stat, go to calculate, and we want to do a quadratic regression of that. So number 5, option, list 1 is X, list 2 is Y, everything else needs to be blank. Crank it out. It gives you the standard form of a quadratic, A, B, and C. This R squared tells me this fits really pretty good. 0.98 is a really good, strong R squared. That means it fits really, really close. Not perfect, but real close. And you would round that. Let's see what we round to here. Oops. Here's our quadratic regression. Those are the values that we just found. Let's round that to 4 decimal places for each of those things. So going 4 decimal places, this would be our quadratic function. So we can build that quadratic function based on that quadratic regression using the tables and then your calculator. Get there. Okay. Now, from there, we can find all of those things that we found with the with any quadratic function. Part C asks us when was the greatest percentage divorce. Greatest would be maximum, right? So that tells us vertex. So we do the math to find the vertex. And we just use the numbers that are there. Use the rounded ones from your function. Find the vertex. So we do that math. We get 55 for the X value. Plug that in. We get the Y value. 55 years is when the age for the greatest percentage from our data that we had. And then to find the Y value, the percentage was 15.8% at that age based on our equation. I'm saying that that's perfect data, but that's the trend of what's going on there. So we're finding those things based on that value. If you graphed our quadratic function on the calculator with our regression there, if you just went to do that, this is the last slide, so I'll go ahead and go there. If I go to y equals and I just type in that function that we had there, get the numbers right here, negative 0.0143 x squared plus 1.5861x minus 28.1886, and I hit graph. See that line going through those points. Doesn't hit every one of them perfectly, but it gets real close to all of them, which is why it's the line of best, or the quadratic of best fit there. The nice thing about that is having that equation is they could ask you what's the percentage of divorce rate for this particular problem for any age. They could ask you for the age 62, and you could plug a 62 in for X and find that Y value. So by finding that equation, you can predict what's happening at any any spot there. But anytime they ask for a maximum or a most or a least or a minimum, they're talking vertex. Anytime, and then you're doing standard form negative B over 2A is what you're trying to do there. Okay? And it's trying to build that out of that. And it's that kind of stuff every time. In these sections, they should be quadratic regressions that you're doing. When you go to the test, for what puts it all together, you'll have some linear mixed in with some quadratic, so you got to be able to tell the difference in which one's which. Some of them will straightforward tell you, hey, do the quadratic regression on this. Some of them will say, look at the scatter plot and decide what's the best fitting. Is it quadratic? Is it linear? And if it has a straight line look to it, it's linear. If it has that little hump to it, it's quadratic. Really, really easy idea there. Really not too bad stuff here. It's just running that calculator is a big deal. Being able to do that, if you can do that well for the last section for sure, and then when you have to write the equation of a quadratic, if they give you 3 points, then it should work out real nice there on the. That's great. On the equations, building the equations from that. So that's it for the week. This is the end.